Alright, this is going to be a video in which I explain how to do sub 1, how to find the VRs. And this is where the dark magic comes. This is the dark magic that I cooked, really. So to start, let's also, okay, one interesting thing about this step is that this can be done purely on paper. So I will not need a cube, really. The only thing you need a cube to is to basically determine the slice state after the skeleton. You just need to record what the slice needs to do, basically. And you don't even need to record it to this precision. But yeah. So I'll just start by explaining what this notation is. So basically, you notice how I haven't really provided a scramble. And this is because, well, it's kind of redundant, because what I can do is to just, I'm imagining some sort of DR state, where if I do this sequence of moves up to just before the pound sign, this solves the U and D layers. And from there, the slice is still scrambled. And if I do R2B2, then I solve the E slice while scrambling the U and D layers, basically. You can think of this as to get to this part of the skeleton from a solved cube, we need to do B2, U, D prime, R2, U prime, D. You can think of this like a scramble for this. If you take a solved cube and do that, this purple sequence, then notice how the U and D layers are solved. And if you do R2B2, you're going to solve the E slice while scrambling the U and D layers. Alright, another thing I have to explain before diving into this method is mod 3 arithmetic, in particular mod 3 addition. Well, this is actually very simple. You can think of this as the mathematics of corner twists. So, for example, +1 minus 1, so you're twisting a corner clockwise and then counterclockwise. This is the same thing as not twisting it at all. Same thing. Obviously, if you twist it counterclockwise first, you get the same thing. If you twist it clockwise twice, you basically get a counterclockwise corner twist. And minus 1, minus 1. This is the same thing. So if you twist a corner counterclockwise twice, it's the same thing as twisting it clockwise once. Okay, this is mod 3 arithmetic. And it's usually denoted by putting 3 lines instead of an equal sign and modulo 3. This is just how mathematicians write it. Alright, so let's get into how to do VR. There are a few ways to actually do this, which are pretty much equivalent. The first one I'm going to show you, I was going to show you multiple ones, 2 really. I'm going to show you Rodney's way and Complex's way, so shout out to them. So this is because I originally came up with something that's a bit more complicated, but they found ways to make it a bit simpler. Rodney's way is like the simplest to explain and to just implement it immediately. So I'm going to start with this one. I don't use it, but yeah. So what you do is, so the first step is to convert the skeleton into a bunch of numbers, and this is really the step that I explained in a complicated way at the start. This is the only difference really between the methods. It's just about how you convert the skeleton to numbers. So the first thing I do, and I'm going to use gray pencil for this, because this is something that you should do this in your head without writing down things. But obviously, I want to explain what I'm doing because this is a tutorial. So I'm just going to use gray pencil for this. So beneath any non-UD layer move, I'm going to be writing R or F in an alternating way. So I'm going to start from the beginning. You can do this from the end. You do need to include R2B2 as well. But yeah. So here I'm going to start R, F. Notice this is U, so we skip R, F, R, F, R, F. We need to include this, R, F. Now, the second thing that we do is that we check the move in the original skeleton and the move in the string of our Fs, and we check whether these are on the same axis or not. So in this case, B2 and R are not on the same axis. B and R are adjacent faces. So this is a minus. So, well, it's -1, but it's always going to be +1 or -1, so I'm just going to write the sign. So basically, if they're on different axes, it's a minus sign. If they're on the same axis, it's a plus sign. So for example, here F2 and F, they're even the same phase, so this is a plus. F and R on different axes, R and F different axes, R and B different axes, L and F different axes, F and R on different axes, L and F different axes, R and R same axis, B and F same axis. This is kind of what I mean by same axis. Okay, these are opposite faces. Okay, so same axis means they're either the same face or opposite, and different axis means they're adjacent. You can also think of it as this. Now I'm just gonna reintroduce this pound sign because I want to make a distinction between these moves and these moves. Also, another thing I'm gonna put is beneath any quarter turn, I'm just gonna put a pipe sign. Okay, because we need to distinguish them. And if we need to find VR sim plus 1 or more, it's useful also to know where the U2 and D2 moves are. So I'm going to put like a dash pipe. Okay. But okay, for a skeleton like this with 4 quarter turns, you generally don't even need to find VR sim plus 1. Because there's going to be a plus 0 or plus 1 generally. So that's not even considered this. But for the sake of the tutorial, I will write down some VR sim plus 1 and plus 2 just to see what you need to do. Alright. Now, next thing we need to do is to determine the goal number. What's the goal number? The goal number is basically the sum of anything after the pound sign. In this case, we have plus and plus. This is minus 1. So this is our goal. Alright. Now, the next thing that we need to do is that we need to pick segments in such a, so what do I mean actually? Let me actually explain it better. So what we're going to do is we're going to pick some of these pluses and minuses. And the way you pick that, this divides this string into segments. So, for example, something like this would be a pick of this minus sign, for example. And we need to do this in such a way that the sum of the segments that we pick, so for example, you can do this, this, and this, in such a way that the sum of the segments that we pick is equal to the goal number, well, modulo 3. But let's be careful, because, for example, this is a terrible VR. This is a VR in a plus 1, 2, 3, 4, 5, 6. This is a VR in plus 6. So this is related to how this become, like, how do we get VR from this? So we want to, if we want to like look for VR sim plus, this is kind of hard to explain, but if you want to look for VR sim plus 0, you basically want the edges of the segment to coincide with pipes only. So one thing that I might do, just to make this a little bit easier to see, is I'm going to sum every number between 2 pipes. So in this case, we got plus, minus, minus, that's a minus, that's a minus, that's a minus. We don't care about the rest. And so now we can pick segments in such a way that their sum is equal to the goal number. In this case, there are only 3 ways to do this, and we only need to pick one of them. So something like this, or like this, or like this. And these pickings correspond to VR. How? So finally, the thing we need to do is after we pick pick segments, we insert an E or an E prime wherever the edges of the segments are. So for example, for the first one, we need to replace this U with a U wide. Okay? And if you can cancel moves, do that. So do not be stupid and write UE, do U wide. That's if the final slicing happens to have UE, then you will realize this in step 2. But for now, just write this as a plus 0. So the first VR is U2, B2, and this becomes U wide, F2, U2, F2, R2, and this becomes D wide prime, because it's at the edge. And then the rest is unchanged. And obviously, you don't write anything after the pound sign, because this is really the end of the skeleton. The second VR would be, so we widen this D prime and this U. And the third VR is basically widening this U and this D. And so these are our 3 VRs in plus 0. I will also very quickly I'll also very quickly show you how to find VRs in plus 1. I mean, not all of them. I will not be finding all the VRs in plus 1, but some of them. So, for example, so let me think. This is a VR in plus 1. Why? Because remember, the edge of the skeleton correspond to the edge of the segments. So first of all, notice how we pick a plus, a minus, and a minus, and their sum is minus, which is consistent. And the edges correspond to where we're inserting a single slice turn. In this case, so the pipes are always 0, and these are this is a plus 1 basically, because if you insert an E or on a U2, that adds a move. This is another example of a VRE plus 1. Okay. Let me just write down what these correspond to. So for example, this corresponds to widening the U2 and putting E slice on top of the U2, which for example, you can do this by replacing U2 with U wide U. Okay. So U2, B2, U wide, F2, U wide U, F2, R2, D prime, B2, U, L2, D, F2, L2. And for the second one, this corresponds to replacing. So first of all, notice how. No, we also need to widen this D prime and this D, but not the U. So wait a second. So this actually becomes D wide. Let me actually explain why that is. So this D prime corresponds to the edge of this segment. So this is widened, but this U, it's kind of hard to see because you don't see the original skeleton. But this U, this is not at the edge of the segment. This is in the interior of the segment, so it actually remains unaffected. Okay, so we only want to insert. This should be wide. We only want to insert slices. You only want to insert slices at the edges of segments. So the second VR in plus 1, for example, this U2 has to be replaced with U wide U, and this U has to be replaced with U wide. And the rest is unchanged. We can also consider plus 2s, VR in plus 2. So for example, let me just. Oh my gosh, what did I say this? All right. For example, this is not an example I'm gonna do later. We can also pick this. So if we want to look for VRs in plus 2, we can do this, for example. This is a plus 2 because notice how the edges of the segment are on dashed lines. So this is plus 1, and then plus 0, plus 0. So this is plus 2. Basically, this corresponds to. I'm just going to write this B immediately. So this is U wide U, E2, U, F2, U wide U, F2, R2, dy prime, B2, U wide, L2, D, F2, L2. So this is a plus 2. Another plus 2, for example, would be something like this. Okay, so notice how if you insert an E slice on somewhere where there are no U and D moves, that's a plus 2. So this basically corresponds to, let me just write what this is. This is U2, B2, U, F2, U2, F2, and now here we need to insert, for example, a U wide U prime, R2, dy prime, B2, U, L2, D, F2, L2. Okay, so yeah, basically the rule is if an edge of a segment corresponds to a pipe, that's a plus 0. If it corresponds to a dash pipe, it's a plus 1, and if it corresponds to nothing, then it's a plus 2, just for the edge of the segment. And then you just need to add up all the edges of the segments. So if you're looking for plus 1, you only want one edge of a segment to correspond to a dash pipe, and the rest to pipes. Or for plus 2, you want either 2 dash pipes and the rest pipes, or one in the middle, like in the middle of nowhere, and the other edges corresponding to pipes. And again, for something like this, where you have 4 quarter turns, you generally will not even have to look for VRs in plus 1. But this is very useful for. So VRs in plus 1 are useful for when you have 1 quarter turn and 2 quarter turns. In VR plus 2, I don't know if I ever looked for those, but they would only be useful for like 1 or 2 returns. Okay, let's just do another example. Now, here I just want to illustrate the fact that if you have a 2e2e at the end, you don't even need to know what the 2e2e is. The goal number is always going to be posterior. So let me actually... I'm still going to be using Rodney's way. I haven't still explained complexes way. So for example, let's just say that this 2e2e is, for example, solved with R2, L2, F2, B2. And I just want to do our RF thing again. So R, F, R, F, R, F, R, F. I'm considering this out. Okay, we'll just do our usual thing. So this is plus, minus, dot, minus, plus, and this is minus, plus, minus. Notice how this actually add up to 0, which is our goal number. So if you have a 2e2e, that's plus 0. This is by construction, basically, due to how I designed this method. Basically, 2e2e is in the VR group, so obviously this would need to be plus 0. This is already a VR. So even without picking anything, this is already VR. But you still need to find all the VRs at least in plus 0. And in this case, there are none in plus 0. Because if you pick any one of these, you get plus, and if you pick both, you get minus. So yeah, but there are VRs in plus 1. For example, you can pick this one. This is a VR in plus 1. Okay, because this adds up to 0, and this corresponds to replaces this u2 with a u wide u and this u with a u wide. And notice how again these moves in the middle they're in the interior of the segment, so they're unaffected. Okay. Now, I also want to explain complexes method, which is what I use basically. And this is a little bit harder to explain. So, and this method, the only step that is modified is the conversion of the skeleton into numbers. And sometimes you might get the opposite answer to someone using the Rodney's method, as in all the signs are flipped. That's the only thing that can happen, besides being in complete agreement. But the VRs that you get are the same, obviously. So the way this works is, so first of all, I have a rule that turns whatever this sequence is into a number immediately. So the way this works is, so we'll make a table. So if you have R2, F2, or R2, B2, actually, let's start with the other ones. If you have F2, R2, or F2, L2, or B2, R2, or B2, L2. Notice how opposite moves are equivalent. This is plus 1. If you have R2, F2, or L2, F2, or R2, B2, or L2, B2, this is minus 1. And if you have a 2e2e, this is 0. Okay. Okay, notice how these rules are only relevant if you have a dr on UD axis. So you need to have different rules for other drs. So that's why this method is a bit more complicated. Whereas with the Rodney's method, if you have a dr on RL, instead of doing RF, you could do UF, US, UF. Basically, that's the only modification. Right. So basically, our goal number is minus 1. Cool. Now, we need to convert this into numbers. And there is another rule. So there is a rule regarding, so we start from the end. And we basically have that F2 or D2 becomes plus 1, R2 and L2 becomes minus 1. And this is, you can think of this as being consistent because F2 and B2 are the start of these sequences here, and plus 1 and plus 1 coincide. And so, yeah, same thing for R2, L2. In this case, we start with L2, and this is minus 1 immediately. So this is only valid for the last one. And now we go backwards. And again, we don't need to write the one. Okay. So now what we need to do is we step back into the skeleton, and if the axis changes, the sign does not change. And if the axis does not change, then the sign changes. So for example, L2 and F2 are on different axes, so the sign remains minus. Different axis remains minus. Different axis remains minus. Different axis remains minus. Different axis remains minus. Here F2 and F2 will do the same move, so the axis changes. Here F2 and B2 are the same axis, so the sign changes again. And from this point onwards, it's the same exact rule. Okay. Now, okay, we have these rules, but how does this term, like, what happens if the DR is not on UD? Because for Rodney's method, all you need to do is, instead of doing RF, you can do UF, 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 or like UR, depending on which two sides are not on the DR axis. Here you kind of need to memorize more rules. But really, you can see how a rule set is consistent if this is the case. So if this F2, so this F2 R2 has to correspond to F2 becoming +1 if it's the last one. Same thing here. But I like to be consistent about this instead of like generating one on the fly. So for me, F2 R2 is +1 if the DR is on UD. If the DR is on RL, then U2 F2 is +1, and if the DR is on FB, then U2 R2 is +1. And then basically what happens is, okay, R2 F2 is -1. And then the rule becomes F2 +1 and R2 -1. And here it comes U2 +1, F2 -1. And here it comes U2 +1, R2 2 -1. And the way I remember this is by remembering that U follows F follows R. So notice how here we have U following F, U following R, and F following R. And these are the +1s. And the first one of these is the +1, and the second one of these is the -1. So, for example, here, U follows F, so U2 will be +1 and F2 will be -1. This is related to the last line. And obviously 2e2 is always going to be 0. This is slightly faster for me, at the very least, because you don't need to do this thing of like repeating R and F in your mind and checking if they're the same axis. You can just start from the end and then keep going and write the signs. So this is slightly faster, but it is slightly more confusing to understand at first. And again, this is like one rule set. You can have multiple rule sets. This is like the conundrum of picking a generator, I guess. Yeah. I don't think there's other things to say at this point. I'll just quickly mention what I proposed originally. Well, not originally. Technically, I only came up with these things in August because I was just doing something a bit more complicated before. What I would say is I would consider like a parity of placement. So I would have these two rules, but they will flip if there's an odd number of non-UD moves after that. But obviously this is the same as complexes method. That's very obvious. I don't think it requires effort to understand that. So for the theory maxers who are waiting for the group theory video, yeah, this is how this works, and I'll be using my parity of placement thingy to explain why VR works. For everyone else, this is dark magic. Just learn the dark magic. I don't know. It just requires group theory to understand it. I mean, maybe there might be some way to express it differently, but like, yeah, it requires a lot of effort to understand it if you don't know group theory. So I guess we'll see in the next video where I explain step 2.